Okay, here we have 2 points and a couple of parametric equations, and we are asked to plot a couple points using these parametric equations and show that the points we plot are equidistant from A and B. So let's just make a little table here. We've got t, x, y. Pick some easy values. How about 0, 1, and 2? Let's see, x would be 5 when t is 0, and y would be 6. If t is 1, 5 plus 2 times 1 is 7. And 6 minus 3 times 1 is 3. And see if t is 2, then 5 plus 2 times 2 is 9, and 6 minus 3 times 2 is 0. I notice that our y values are going down by 3. The negative 3t would tell us that. And that our x values are going up by 2. The plus 2t would tell us that. And also our starting point, which isn't really accurate, but we could think of it that way, is 5, 6. We could think of that as more of an initial condition, perhaps. But it basically means that when t is 0, we're at the point 5, 6. So we can plot those points. So let's see, 5, 6, 1, 2. Ooh, man, hold on a second. But a sneeze coming on, and then it just went away. Oh. 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5, 6. 7, 3. So that's 7, 1, 2, 3. And 9, 0, which is right here. So it looks like we'd be plotting this line right here. And we'd want to show that these points are equidistant. So here we could do this calculation. 2, 3, 2, 3, which would make this the square root of 4, 9 square root of 13, square root of 13. Here we have here for this point we have 1 and 1, 2, 3, 4, 5, which makes this the square root of 26. 1 and 5, square root of 26. We could test this point out down here. Let's see. That is 1 and 1, 2, 3, 4, 5, 6, 7, 8, which makes this distance here, it's getting crowded in there, from here down to the axis, 1 and 8 square root of 65. And here, 3 and 1, 2, 3, 4, 5, 6, 7. 3 and 7 gives us 9 and 49. Wait a minute. Oh, I'm marking from the wrong point. That's 4. It's from up here. Sorry. 16 and 49 is 65 again. Okay. So one thing to look out for here is, remember, if you calculate the slope from A to B, it is 2 over 3. And if you look at the slope of this line, it's going to be down 3, forward 2, down 3, forward 2. And we see that from the line down 3, forward 2, which is a slope of negative 3 over 2. And notice how 2/3 and negative 3 over 2 are those negative reciprocals. Again, technically the definition of negative reciprocal is that they multiply together to make a negative 1, but we think of it more, usually we think of it as, I take one fraction, I flip it upside down, and change its sign. And that's what negative reciprocals are. And if the two slopes are negative reciprocals, then they are perpendicular lines. And in this particular case, this particular perpendicular line passes through the midpoint of A and B, which makes it a perpendicular bisector. And the perpendicular bisector is the set of all the points that are equidistant from A and B. Right? So there you go.